A very good afternoon to you. My name is Aloysius Zhen Wu, metric number U1722355K. And today I'll be giving a simple demonstration of my final year project, a federated learning study. To start off, what you see on screen right now is the framework for my federated learning project. The framework for the federated learning process consists of two components, the client component as well as the server component. The server component consists of the server scripts, the database, as well as the orchestrator and aggregator scripts, while the client component contains solely the client script. To start off, users can use the server script to create global models, and they have an option to choose whether to deploy the deep reinforcement pruning framework or not. In the event that the users choose to deploy the deep reinforcement pruning framework, they are able to choose the sparsity level that they want to train the global models on. Subsequently, the global models is saved in the database folder. The orchestrator will next expose the database folder to incoming client connections. On the client side, the client will initiate the client script to establish communication with the orchestrator. Subsequently, they will retrieve a copy of the global model in the database on the server side. Subsequently, they are able to train the copy of the global model locally on the client device, and the client can send back the locally trained model back to the server for weight aggregation. Without further ado, let me show you a simple demonstration of this whole framework. What you see on screen right now is the two VNC viewers, namely the Raspberry Pi 3 and the Raspberry Pi 4, which will be used to simulate the client side. Below, you can see the server component, which houses three different folders, namely the database, the orchestrator, as well as the server. The server folder contains the model creating scripts and the option to create for the user to create a deep reinforcement learning pruned model or not. When the model is created, the global model is created, it will be saved in the database folder in the form of PTH. Subsequently, the orchestrator will be run, and the orchestrator will expose the saved state dictionaries of the global models. So firstly, let us run the orchestrator. Once the server is started, the client can then initiate and establish communication with the server. Do note that the WebSocket communication has a limited bandwidth. Therefore, a chunking process is being implemented to chunk and split the saved state dictionary of the global model into smaller byte formats for transmission and receiving. After the copy of the global model has been finished locally, we can see the results of the training process, and subsequently the model is sent back from the client side to the server side for further aggregation against the global model. Once the model is sent back from the client side to the server side, the communication is cut off, and there's no need for communication between the client and the server anymore. So with that, I have demonstrated the simple federated learning framework that I have implemented. Thank you very much.